In this question, a copper-64 atom undergoes nuclear decay according to the following equation. We're starting out with copper, which has an atomic number of 29 and a mass number of 64. So we've got copper. An atomic number of 29, that means it has 29 protons. A mass number of 64, that means it has 64 protons and neutrons together. So if we take the mass number 64 and we subtract the atomic number 29, that will give us the number of neutrons, which is 35. So we've got 29 protons and 35 neutrons in our copper atom to start with. Then on the other side of our equation, we have nickel with an atomic number 28 and a mass number 64. So atomic number 28 means we have 28 protons, and a mass number 64 means we have 64 minus 28, which is 36 neutrons. Then we also have something labeled beta, but it has a +1 this time for the atomic number and a 0 for the mass. Now that +1 tells us it has a charge of +1, and the 0 tells us it has no mass. Usually we have a -1 there, showing it's an electron. The +1 is showing this is a positron. A positron is the antimatter equivalent of an electron. So it's like an electron, but it has a positive charge instead of a negative charge. So that beta with the +1, that's a high-speed positron. And then we also have this, which is a neutrino, which has 0 charge and 0 mass. So 0 atomic number, 0 mass number. We've already encountered the antineutrino, which looks like this. That bar on top is what tells us it's the antineutrino. Here we just have the neutrino. So the neutrino and the antineutrino are antimatter versions of each other. Okay, so our first question is, what is emitted when copper-64 decays? Well, we can see we've got a positron and a neutrino emitted. So there's our answer there. Next, which of the following describes what happens in the copper nucleus in this process? So let's take a look at the equation we've drawn out here. We start with copper, which had 29 protons, and it turned into nickel with 28 protons. So we've lost a proton. We started out with copper, which had 35 neutrons. We ended up with nickel, which has 36 neutrons. So we've gained a neutron. So what's happened in this case is one of our protons has actually turned into a neutron. That's why we lost a proton and we gained a neutron. And as the proton turns into a neutron, it also emits a positron and a neutrino. So that's going to be answer B here. So we can select B. And what is the name for this process? Well, this process is positron emission. You'll notice this looks very similar to beta decay. In beta decay, a neutron turns into a proton and emits an electron and an antineutrino. This is kind of the opposite of that process. In this one, protons turns into a neutron, produces a positron and a neutrino. Let's do one more question. In this question, we have a chromium-51 atom undergoing nuclear decay according to the following equation. Again, let's go through and analyze our equation. So we're starting out with this chromium atom here. And we can see we have an atomic number of 24 and a mass number of 51. So an atomic number of 24 tells us we have 24 protons. And a mass number of 51 tells us we have 51 protons and neutrons together. So if we subtract from our mass number the atomic number, the number of protons, that will get us the number of neutrons, which is 27. So we've got 27 neutrons. Next we have an electron with a -1 for the atomic number, representing a -1 charge, and a 0 for the mass number, representing no mass. So we've got an electron. Then on the other side of our equation, we have vanadium, which has an atomic number 23 and a mass number 51. Atomic number 23 means 23 protons. Mass number 51 means we've got 51 protons and neutrons together. So if we subtract the number of protons, which is 23, that will get us the number of neutrons, which is 28. So we've got 28 neutrons. And we also have this V symbol, which represents a neutrino. That has 0 for both the atomic number and the mass number, which represents 0 charge and no mass. So that's our neutrino. All right, so what is emitted when chromium-51 decays? The only thing emitted is a neutrino. Now next to describe what happens in the chromium nucleus in this process. So we started out with 24 protons. We gained an electron and we ended up with 23 protons. So we've lost a proton there. We started out with 27 neutrons. Then we gained our electron and we ended up with 28 neutrons. So we've gained a neutron there. So we've lost a proton, gained a neutron. So that means we had a proton, we added an electron, and we ended up with a neutron and the empty neutrino that was emitted. So that describes what happens down here. We had an electron. It's from an inner shell, captured by the nucleus, combines with a proton. That's what we got here, our electron and our proton combining together to form a neutron, which remains in the nucleus, and a neutrino, which is emitted. And that's exactly what we saw in our equation. So C will be our answer here. So what is the name for this process? This process is electron capture. It's where the nucleus captures an electron from one of the inner shells, and it combines with a proton to form a neutron and a neutrino. So those are our two new types of decay. We had positron emission and electron capture. You already know about alpha, beta, and gamma decay, so I'm not going to go over those again, but you can see those in the previous skill if you need more practice.